Welcome to the second lecture in Math-Based Tutoring's course on PreAlgebra. It's offered for free by Math-Based Tutoring, a company that offers tutoring for all levels of junior high, high school, college algebra, calculus, linear algebra, and differential equations. Check us out on Facebook at facebook.com/math-based tutoring. This course has a textbook that is available for free online. It's based off this textbook. It's available at Rice University's openstacks.org at the web address below. If you have bought a paper copy of this textbook, which I highly recommend doing, we'll be on page 9. If you're following along in the PDF, we'll be on page 11. Let's get started with place value. So our number system uses a place value system, and it is called the decimal system. Decimal, meaning 10, deci, means we have 10 digits in our number system. And those digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this place value system, each number is assigned a place value. And the position of the digits in the number determine the total value of the number. Money is a familiar model of place value. Let's say somebody gave you $374. Well, they would give you 3 hundreds. Well, in this case, a $100 bill represents 100. So we have 3 of those. And notice that in the hundreds place, we have the number 3. And then this is the tens place, which would be $10 bills. And there's 1, 2, 3, 4, 5, 6, 7 $10 bills. So that represents 7 tens, which would be $70. And there's 4 ones, which represent 4. So we have $300 bills. Each represent 300. 7 $10 bills. 7 times 10 would be $70. And 4 $1 bills. We're going to run out of... We could probably do this with a 4-digit number with $1,000 bills, but I don't think there's too many $10,000 or $100,000 bills laying around. So this pretty much covers just the small values of numbers. But if we add these up, 370 and 4, we get the number $374. Place value is very similar to blocks. We can use base 10 blocks to represent 4-digit numbers and smaller. And blocks are used to represent thousands, hundreds, tens, and ones in those places. So a single block, as we did with a $1 bill, represents 1. And if we line up 10 of those, that would fill up the second row, which would be a tens place. And then when we line up 10 of these tens, we get a square, which represents 100. And what's not shown here, if we have 10 hundreds, we have a cube, which would represent 1,000. So let's consider a number in base 10 blocks. Let's look at the number 138. So here we have 100, 3 tens, which we see a 3 in the tens place, and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. To represent the number 138. So we look at each of these. The digit 1 represents the hundreds place, and that value is 100. And the total value of this place is 100. And then we have 3 tens. Each value would be 10. And 3 times 10 is 30. So the total value of the tens place would be 30. And then we have 8 ones, where each one of these individual blocks represents the value 1. And 8 times 1 is 8. So if we add these up, we get 138. 138. All right, example 1.2. Again, these videos correspond to You Try It videos. I suggest you try them on your own afterwards so that you get a basic understanding, and the answers are in the video description below. I'll link to You Try It video 2. We're going to use place value notation to find the value of the number modeled by the base 10 blocks shown below. Okay, so each of these blocks, again, represent 100. So we're going to have 2 hundreds. And there's only one 10 block here, so the tens place is only going to be 1. So the value of the tens is 10. And then there's 1, 2, 3, 4, 5 ones. So if we add these up, we get 215. So the value of these numbers in the base 10 blocks shown here represent the number 215. I appreciate you watching. If you have any questions, drop us a line on Facebook or answer a comment, ask a question in the comments below. I appreciate you watching, and we'll see you soon in Lecture 3. Thank you very much for watching.